Alright, moving on with the next section of the review. This is converting equations back and forth between polar and rectangular. Let's look at these three examples, and here are the formulas that we're going to be using right here. I will not give you these formulas on the test. You need to know those, but we're going to have those sticking right there just for reference. So I want to convert x's and y's into r's and thetas. And so the whole time I'm doing this, I'm peeking over here at my formulas, and I'm hoping to steer towards one of these formulas. And what I see in number 12 here that I like is an x squared and a y squared. And I can see right here that x squared plus y squared equals r squared. So if I want an x squared plus y squared, I will simply add this y squared over. Add over the y squared. And that gives me x squared plus y squared plus x, and on the right side it equals 0. And now I can take out x squared plus y squared, and x squared plus y squared does equal r squared, it says so right here. And then all I have left is this x, and I can take out x because x is equal to r cosine theta. So I'll take out x and I'll plug in r cosine theta. Adding those two things, they equal 0, and that is where I am going to finish. So there's your equation. The next two are actually a lot easier than this. I have x equals 2, and x is equal to r cosine theta, so I'll simply take out the x, and I'll plug r cosine theta in its place. And then if possible, if it's easy, I'm going to solve for r, so I'll divide both sides by cosine. You don't necessarily have to do this, but this would be a good multiple choice type question. And if it's multiple choice, your answer will probably be in this form, r equals 2 over cosine theta. Or if I'm really sneaky, 1 over cosine is equal to secant. Secant and cosine are reciprocal, so this is the same thing as 2 secant theta. You can't forget those identities. Now, I don't know if I'll be that mean to you and put that as multiple choice, but technically y'all should know that, so I guess it's fair game. Should I do that? I don't know. Alright, let's see. X equals negative 2y. You're going to do the same thing. X equals r cosine theta, so I'll take out the r cosine theta. Equals negative 2y, and y we know is equal to r sine theta, so we'll take out that and plug in r sine theta. And there we go. This one's a little bit tougher to solve for r, but I'll show you how to do it just in case you're curious. I'll add 2 r sine theta to both sides of the equation. And that will give me r cosine theta plus 2 r sine theta is equal to 0 because everything canceled on this side of the equation. Then I can factor out, wait, does equal 0, doesn't it? You know what? This is a bad idea because this is going to end up backfiring on me. So x equals negative 2y. We'll actually just leave it. So I just kind of wasted a little bit of your time. That's okay. I thought I was trying to show off my skills, and that was going to end up backfiring on me. So we'll just pretend that never happened. That never happened. We'll throw this thing away. And here is the answer that I would actually be comfortable with. That's what I get for trying to show off. Alright, so there is converting some rectangular equations into polar. The more difficult type, though, is converting polar into rectangular. So here are our formulas over here. And what I want to do is somehow steer these equations into something like this. I'm looking at 15, and I see r equals 2 sine theta. This would be great if I had an r with the sine. So if I want to put an r with the sine, I'm going to multiply this side by r, and that would actually give me 2 r sine theta, which is good because r sine theta is equal to y. But if I multiply the right side by r, I need to multiply the left side by r as well. So that would be r squared equals 2 r sine theta. And then, remember, we're trying to get out of polar form into rectangular form. So you don't stop until you have only x's and y's as your variable. We know that r sine theta is equal to y and we know that r squared over here, r squared is equal to x squared plus y squared. It says so right here. So x squared plus y squared is equal to 2y. And there's your answer. Let's see. This one we're going to actually do the same thing. I have cosine theta. I really wish I had r cosine theta, so I'll multiply both sides by r. That would give me 3r squared equals r cosine theta. And we'll just do the exact same type of substitution. R squared is x squared plus y squared, so it'll be 3, and instead of r squared, x squared plus y squared. And instead of r cosine theta equals x. So there we go. Good, good. Let's see. I need to sit back there so you can sit there in all of my wonderful work. Okay. This one is probably the most difficult one. R equals 4 over 1 minus cosine x. What I'm going to do here is multiply both sides by the denominator, which was 1 minus cosine theta. And if I multiply the left side by 1 minus cosine theta, on the right side what happens is the 1 minus cosines cancel. I have 1 on top and 1 on bottom, so my right side leaves up to just equals 4. That's all that was left. On the left side, I'm going to distribute my r through this set of parentheses. So r times 1 minus r times cosine theta. And now I'm going to see what I can substitute. I do know that r cosine theta is equal to x, so that's going to come out as x. I know that r, I have an r by itself, that's equal to the root of x squared plus y squared. And that was r minus r cosine, so it will be that minus x equals 4. And there's your answer. Good, good? Good, good? Alright, this last one right here, r equals 3. What I'm going to do here, even though I could take out the r and put in the square root of x squared plus y squared, what I'm going to do is square both sides. I'm going to square both sides of the equation. That would give me r squared equals 3, and then r squared over here is equal to x squared plus y squared. So I'm going to say x squared plus y squared equals 3 squared is 9. There, equals 9. And that'll be your answer. And we do need to do it that way because if you think about the graph of r equals 3, in polar equations that is a circular graph with radius 3 around the origin. And in order to have the entire circle graph, it needs to be in this form, x squared plus y squared equals 9. You don't want to do the square root of x squared plus y squared equals 3. So there we go. That is 18, and I think that's the last one. Yeah, that's the last one I wanted to do in this video.